Okay, so everybody, welcome to AtCoder Beginner Contest 192. I'm afraid we may experience some connection issues this time around, but it should not affect the contest overall for us. So let's see how we do. Hopefully it goes better than the previous time. So yeah. Can immediately open this one and this one. Yes, the problem A star Takahashi is playing a game. In the game, each time number of coins you collected so far becomes a multiple of 100, you get a prize. Takahashi collected X coins so far. How many more coins does he need to collect before he gets the prize? Okay. I'm thinking, first thing you do is this, then like this. Oh wait, you mean like it's actually very simple. So I don't even, we're interested in the next prize, right? So, and this is not the correct file, but whatever. Okay. Yeah, I'm pretty sure this is correct. Yes. Okay. Problem B, unreadable string. We call a string hard to read when it's odd positions, so first, third, fifth, and so on. Characters are all lowercase and even positioned are all okay. So we're just gonna do what we are told. I think the output is yes and no. So like this, because we start from 0, this actually means that we are in the even position. So we should check if it's uppercase. So hard should get what? SI is uppercase and has like this and like this. Or actually, the input format is a bit different. Output format is a bit different, so I have to do it like this. Answer should be yes, no, yes. So yes. I'm pretty sure we are all good to go. Or the space characters ransom. I think it does not matter for our solution. Okay. Problem C, Kaprekar number. For an integer x not less than 0, we define g1, g2, f as follows. g1 is the integer obtained by rearranging the digits in descending. g2 is in ascending. F is the difference between descending and ascending, obviously not negative. For example, given integers n, k, and k in the sequence defined, find ak in the sequence defined by what? That's okay. Whatever. Like, do I actually? Well, that's annoying a bit. I was thinking Python it would be much easier. I mean, there are not many digits, so we can afford ourselves. Push back the least significant digits, divide n by 10, return r. Digits from least significant to most significant, so this is a problem. Python would have been much faster. More or less sure that we want something like that, so now we just got digits of n. So I mean, with k up to 10 to the fifth, the only thing we have to do is to simulate this quickly. I think that the numbers do not get like really high for some reason. Yeah, the number of digits does not increase, should not increase at least. Once we did this and this, we can do this. I think compiler optimized some things nicely. I'm a bit suspicious about all these small sorts to do, but they should be like pretty efficient, I think, in C++. First things first. This is incorrect. Most probably because this should be here and this should be here. Yeah, sounds pretty quick to me. I think we can submit this. Actually, now I'm not sure. No, okay. I thought for a second that maybe we need like long integers because, well, yeah, no, I actually don't know why this passed. This should not have passed. I can very easily construct a case when my solution does not pass. Okay, whatever. Problem D base n when given a string x consisting of 0 through 9 and an integer m, let d be the greatest digit in x. How many different integers not greater than m can be obtained by choosing an integer n, not what? Can you please structure your sentences so that they operate on at most 3 objects? I don't understand sequences of sentences of such lengths. We have a string x, which is 0, 9 sequences. M is an integer. D is a max digit of x. We want to count integers n such that they are at most m. N should be at least d plus 1. Then we say that x base n equal to n. Oh my god. Oh. This is complicated. No, wait, can we just check? Like we select the base, right? We want to find the max base that we can select. Clearly, base should be at least max digit of x plus 1. But then, like, x is monotone. Yeah, this is a binary search. No, actually. Amazon. Okay, okay. So the smallest value for the base is d plus 1. D plus 1 does not necessarily work. Okay, so because we're going to subtract d, it does not matter. High should not work. Why high does not work? Well, wait, if x is just 1 or like 9, Then we don't, if length of x is 1, then we don't get multiple different integers. Okay, so this makes sense. So if length of x is 1, I should have a separate branch because yeah, I don't need this. If length of x is at least 2, and then max base we can like x is at least 10 in this base, which means that its value is at least the value of the base, and n plus 1 as the base won't work, because then x is at least n plus 1. Yeah, we are safe when we add like this. Uh, if flow stays d, then the answer is 0 because like no base works. Okay. If length of x is 1, however, I think this is equivalent. I'm pretty sure. May have a problem here. Like what if it actually overflows? Right? What are we going to do? Just curious, do I have something like this here? Or should I check something like x is for x in where? Or x in where? Like the usual thing is like this. Is to have power, starts at 1. Power also gets multiplied by base. And you add this. Wait, actually. No, we do not reverse x. You got highest digits first, so they get multiplied, then we just add this, and it will get multiplied by power later, by base later. But here, there is a problem, like this can very easily overflow. I'm not actually sure if this works. It sounds like a reasonable way to avoid overflow. Well, the last case looks like it's going to check our behavior. What? Line 20, x, oh, x0. Oh, okay. Where is it? Answer is 2, which is correct. Answer is 3, which is correct. The answer is 1, which is correct. Should I test more, or does this trick does the job? I think it's pretty safe to submit. Not like entirely sure, but should be okay. Well, worst case scenario, we'll just fix it. Okay. It took me a while to implement, actually, like 10 minutes. Problem E-train in the Republic of AtCoder, the end set is numbered 1 tram. The M railroad connects at time 0, Ki. What? Okay, at time 0, Ki, well, all subsequent multiples of Ki is this terrible word, like 0 Ki, 2 Ki, and then you put 3 dots and everybody understands you. But this time, comma, and then words, it does not make sense. Train departs from each of the cities and head to the other city at the time. It just trains takes to reach the destination is Ti. Okay. You are now at city X. Find the earliest time you can reach the city Y. When you start the journey by taking a train that departs city X much earlier than time 0. Okay. So it's like shortest path, but not really. Sounds interesting, actually. Hmm. Mm. We generated some graph consisting of edges, which is good. But what do we want to do now? Now, I should think more. NM, okay, so the actual sync is X and Y are here. Then we want to find the shortest path from X to Y with all these things. It's more or less the standard shortest path, right? So I'm just going to grab my Dijkstra real quick. That's, I think it's reasonable. Well, it actually uses some somewhat different approach to the structure of an edge is different, but not significantly. Priority queue stays the same now. Here, there is some difference. Yeah, we don't need this, we don't need this, don't. Oh, we do want this. The only difference should be when we decompose an edge. Edge length DIES, okay. Interval. So the closest distance plus edge length is not exactly what you want. You want to the first multiple of interval that you are going to encounter. So I think we want something like this. So this is closest distance plus edge length over interval rounded up. And there are several problems. Yeah, I don't care, man. Well, actually, I do care about this thing. It's reasonable not to do anything if you reach the destination vertex. Should be a source of some speed up. Actually, you don't even want to return the entire vector. You can just not break, but return. And if not reachable, then what do I have to? Okay. Closest distance, I believe. From G, X, Y. E1. Okay, I agree. I'm not sure if this matters, but this actually is interesting. What do you mean there is no such function. Do I really have to? Okay, let me just copy it real quick. Is this no, this is not a correct answer. Oh, okay, because we have interval time. No? This is still clearly incorrect. Interesting. This is still incorrect. Well, maybe we at least, yes, okay, we at least get this. We use graph. We use like only really only here. We take source, adjacent, interval, edge length. I'm not sure actually that under these conditions, you always fit into in64T, but maybe you do. Maybe you do. Like, yeah, okay, you actually do. Okay, so it does not match. I don't really understand what happens here. This time is distance to current vertex plus edge length, which is the same as time, right? No, wait. It's not interval time. It's time interval, right? Time, then interval. Again, this and then this. That's unfortunate, but same time should not affect us a lot. But it does. Okay, so clearly something is not working. Like we always return 1. Why? Oh my, oh my, oh my. Of course, we always return 1. What I was thinking about. Oh, this is incorrect. This is incorrect because we actually want. Yeah, I think the real formula is like such. So we wait until we can depart. Yeah, oh, we actually have one more sample test case. Let's check it out. That sounds very reasonable. The idea is that we first wait until we can leave, and then we add the traveling time. Okay. How are we doing? 35 minutes? Okay, not all that bad. Problem F potion. There are n kinds of materials. Material I has magic power of AI. Takahashi, the magician, wants to make a potion by choosing one or more kinds of these materials and mixing them. At the moment when he makes a potion by mixing k kinds of materials, the magic power of the potion is the sum of materials used, and every second's magical power increases by k. Note the increase of the magic power is a discrete, not continuous process. Okay. Takahashi will mix material just once at time 0. What is the earliest time he can get a potion with a magic power of exactly k? Exactly k. Well, that's interesting. Yeah, sure. Right. It's already clear why we can always make such potion. We can just take one and then wait second by second. It's not clear how to solve it. Not at all. Uh, Unfortunately, we can't just try all subsets, clearly. What if we fix the size? So let's say we take 57, then what do we get? Want our initial thing to be divisible by 57. I want to find max subset sum that is divisible by 57. Want to do it from 0 to 100. What is the right way to do it? We'll just store max value. Yeah, okay. It's very clear how to do it. Yes. Max size is n plus size. Time equals, well, why not, right? Because we're interested in everything modulo size, then for auto AI in I for int remainder from 0 to size, increase remainder, dp at remainder plus AI size equals max of, no, actually, dp is initialized with 0, which is strictly speaking not true. Wait, but then we want only subset sum equal to yes. Well, we can make two-dimensional DP, right? No one will game to stop us. size plus 1, I believe. Actually, let's say that first is size and second is remainder. Now here, like you actually want to do this. Then what goes here as size, remainder plus AI. Right? Right. It should be pretty clear what are we doing here now. So this is when we do take, and when we don't take, like nothing changes, right? Well, we don't take, nothing changes. So. Because we have at most 100 portions, it fits exactly. That's why AI is up to 10 to the 7th. It's like whatever sum we take, it won't exceed. So now, wait, that's the p size and then x modulo size. I am pretty sure. We want this remainder. Yeah, dp, yeah, okay. Mean time gets minimum of mean time and x minus best over size. This is not a correct answer, but we'll fix it soon. Well, this is a correct answer. Okay. So this is the size of the subset that we want to get. Like, how are we going to do this? We create dp, which is subset size and remainder. Yeah, because there's -1. Which I conveniently forgot about. Not equals, not equals. The idea is that you don't want to propagate impossible values. No, the problem was not here. Interesting. Well, okay, yes. Also forgot to make this check. Oh, it's still wrong for some reason. Here we have 3, 6, 8. And something is wrong. And this is going to be the max sum possible with given subset size and given remainder. how are you going to calculate? Like initially it's all negative ones, which means impossible. There is a subset of zero size and zero remainder. Modulus size. Then we loop our all AIs, loop our all possible values of size over all possible values of remainder. Oh, actually, like it propagates forward. And then it may use it again, right? This is not what we want. I agree. I think we actually want a loop like this. Because currently we can use the same AI twice. Like, look, what happens this time? If this is possible, and we try to add like further observations, which means that we once try to use AI twice. Yeah, this is a common trick in backpacking. Don't want to pack the same item twice. I think we are going to submit, so worst case scenario, we're going to get a penalty and have any unnecessary ints. Good. So we solved everything in 47 minutes, which is, I believe, is fastest than we ever did. Let's actually see how it translates to standings, because it's often like I don't really understand AtCoder standings. Sometimes I see something that I completely did not expect. Well, we're 56, which corresponds to the fact that we did our best. But clearly we are far from just insane in 4 minutes to solve what I was doing like 12 minutes. But at the same time it's not bad, because well, first of all, no wrong submissions, right? So we are not going to drop any further in the standings. Well, we are faster than an Anand because he had three wrong submissions on a completely unnecessary problem. D. What is D? Man, like, the funniest thing about me in contests is that I, like, seconds after I solve the problem, I completely forget its statement. I can't tell you what was D about. I just can't, man. It's impossible for me to tell. Right. That's the tricky part. I'm glad that I thought about it in advance. But otherwise, he was a bit faster here. Faster, still faster, slower. That's not clear why it took him so long. Or maybe that thing with size that you can just, yeah, it may not be trivial that you can just add random things in your DP and it will still work. A couple of my friends trying their best apparently to solve problems. It's great to see more people practicing. Like, it's really fun to do CP notes alone, I'm telling you. So, yeah, I think this is it for the screencast. And if you want some more detailed explanations, then you can watch an editorial, which will come out very soon. So, thanks for watching and see you next time. Bye-bye.